Welcome to IESA AI Summit. I'm Sridevi Devi Reddy, bringing you the product showcasing product demos of participating companies. The first one being MosChip. MosChip is the first fabless semiconductor company from India, which has been designing chips for the past 20 years. We have with us Mr. Swami Irinki, VP of Marketing and Business Development. Mr. Swami is a marketing and business development executive with over 25 plus years of experience in high technology companies and public companies. He is responsible for MosChip's long-term strategy for growth in semiconductor and embedded systems business units, along with North America business development, sales enablement for turnkey ASIC and design services. He will enlighten us today on ASIC platform for AI-enabled edge devices. Welcome, Mr. Swami. Sorry for disturbing you at this middle of the night as you're in US. Now over to you. The stage is all yours.
Thank you, Sridevi, for the kind introduction. Let me share. Should share my presentation. Yes. Thanks, Sridevi, for the introduction. You can see my screen, right?
We can see a screen.
Okay, thanks, Sridevi. I want to go in a presentation mode. Let me see one second. Yeah. Yes. So with this, as Sridevi mentioned, I'll be going over the ASIC platform for AI-enabled edge devices. As you heard from the in the summit so far. Why can't I go down? One second. Why can't I navigate to the next slide? Looks like I should be in yes, it's working now. So the main agenda for the topic will be to cover what's happening, how the AI is enabling edge devices, and why there's a need for ASICs to develop edge devices, and what MosChip is doing in creating these ASIC platforms, both for silicon development and for software development. And I'll conclude with some topics, with the conclusions, with the Q&A at the end. So as AI is definitely migrating to the edge, initially the AI, a lot of training is still happening at the cloud and at the edge of the network, but the inference definitely has moved to edge devices, because the processing closer to the data improves the latency, bandwidth, energy, and it reduces the stress of the network. So that is actually driving many of these applications like automotive, consumer enterprise robotics, and drones, and AR, VR, security cameras, and security speakers. So there's expected to be a 2.5 billion devices in this AI edge device shipments by 2025. I'm giving a little background prior to showing why ASICs are important for edge devices, so that I can show the ASIC platforms enabling these applications. So what's happening in the embedded AI and security is driving a new renaissance in silicon development. All the people in India, all over the globe, who are working in the silicon industry should be very. It's a golden era for silicon development, either in the hardware design or software design, because the many new applications are driving. Is going to be tremendous growth in semiconductor industry. For example, in IoT, there are several applications in IoT driving these edge devices for embedded AI and security. For the AR, VR, there are many applications that are driving this edge devices, which are going to be smart and secure. Automotive applications and mobile that we're all very familiar with, plus the industrial applications and security and the smart surveillance. So all these applications are coming. They all need embedded AI and security devices. But what's happening is these devices are not made equal. And that's where the beauty of the ASICs will come in. It's not necessarily, it's not possible. Some devices, as you see on the left-hand side, some are very cost and power sensitive. They depend on battery life. They want low cost. They want always on sensor hub. Whereas some applications like AR, VR, or a dashboard for automotive application or drone, they're more compute intensive and latency sensitive applications. So it is not possible a general purpose CPU or a GPU or ASSP will cover all the applications, and one chip will not be able to cover. That means you need a domain specific application SoC, and that's where the ASICs are better suited for providing a domain specific for a given task and the best optimized solution. So that is where many companies are developing ASICs, and MosChip enables. We don't develop our own products. We develop ASICs for using our ASIC platform. Other companies develop their products, and ASICs are better suited for high performance processing with a low power consumption and form factor, which is extremely critical for edge devices. And ASICs are optimized for a specific application compared to GPUs and FPGAs. And ASICs can deliver AI functionality at a low price point for the unit price, but it requires some upfront NRE investment. And most of the edge devices can be developed in mature process nodes of 22, 28 nanometers and above, whereas the cloud training, etc., you need to go to 7 nanometer, 5 nanometer. For edge applications, for inferencing, you can still leverage the older process nodes. So with that background, let me now say that sets the stage why ASICs are important for edge devices. Now, the ASIC platforms that MosChip is enabling enabling our customers to develop their solutions for inferencing and security edge devices. As I mentioned, MosChip enables our customers to develop their products. So we want to develop platforms so that we can lower the risk and faster time to market and etc. The first platform that I'm going to talk about is our platform called Matrix One. It's a platform for multimedia handheld applications that we developed in 40 nanometer. It's fully silicon validated for all the multimedia type applications. All the interfaces are fully validated, and all the software development we have the complete reference platform. Our customer can leverage it to develop their edge ASICs in 40 nanometer. But this platform it was developed about a couple of years ago, does not have an inference engine, because AI is, as we all heard, it's pretty new. So this does not, it has security, but it doesn't have an inference engine. So what we're doing is we're upgrading this platform to 28 nanometer, and we call it as Matrix 2. In 28 nanometer, we leveraging all the work that was done in 40 nanometer, because a lot of interfaces are fully validated and vetted in silicon. And we are upgrading that platform in 28 nanometer to add a MosChip's internal IP for mixed signal SerDes IP, and CEVA's neural network engine, and secure IC security IP, so that this platform can be leveraged more for smart and secure edge devices, for set-top box applications, smart metering, and handheld applications. So the key IP blocks for this platform will be MosChip's internal mixed signal IP, because most edge devices are actually they will be towards the real analog based for sensors. They talk to the real world voice and audio. So mixed signal IP is going to play a critical role in this applications. And MosChip has a protocol agnostic SerDes PHY that supports up to 16 gig. That will be part of this Matrix 2 platform in 28 nanometer. The other key building block we're enabling in this platform is our partner SIBA. It's a very well-known company based out of Israel. They have a very strong portfolio of neural network engine, and this engine it talks for a single core. It supports about 12.5 tops. In a multi-core, you can go up to 100 tops. And this neural network engine can be configured for a given application. As I mentioned, each domain is different. A drone application is different from a security camera. So it can be configured for a custom domain application. We can customize this neural network IP into our platform so that we can develop a domain-specific NNP IP through our platform and enable our customers to develop that ASIC for that application. And another critical IP is security. The reason I think the original IoT assumption the market had did not proliferate because the edge devices were not secure, and there are many attacks happened that the people got attacked through the weak edge devices which are not secure. So now industry is all the customers are focusing on edge device has to be not only smart, AI enabled, but secure. So for that, our platform will have a securizer IP from our partner SecurIC, and this securizer IP it plugs into the system interconnect and provides all the security for all the critical AI protections for the confidential, the data, authenticity, secure boot, runtime integrity, and tampering solutions. And it's a hardware solution. The hardware security is much more secure, and it works. It runs faster. And there are some software angles, optional features available, but the critical functions are implemented in hardware through our platform on the Matrix 2. So that is the second platform I covered. The third platform that I like to cover is that we developed with our customer in 22 nanometer, which is a platform with our embedded MRAM. So what's happening is that the on-chip memory-based emerging non-volatile memories is actually providing a better access speed and lower power, which is very important for some variables type of applications. So we actually developed this platform fully silicon validated in 22 nanometer with a full software development track with a custom embed RTOS, etc. So we can leverage with different derivatives. We can derive for MRAM based edge ASICs from this platform for the customer. So I covered three platforms: one in 40 nanometer, 28 nanometer, and one in 22 nanometer. And these are all for silicon platforms. But as you heard from this conference to date, another big puzzle or equation is the software. The software and the firmware is extremely critical for these edge devices, right? So that's where a lot of these models come in. So MosChip also provides system design services for the firmware software development and the bring up, etc. So in that area, our capabilities are we have three capabilities in that area that we were expanding more. One is object detection classification. We've actually implemented that project for a customer. You can see the GUI here, and we also have our MosChip pre-engines can provide data augmentation to enlarge the data set because you may not have the larger the data set, you can do better modeling and better accuracy. So we can enlarge the data set with our pre-processing engine. The third capability is a face detection and recognition solution is developed by the team in Hyderabad. This team you see on the screen, they developed this capability, and that is the case study that I'm going to show today as a demo. And that case study is, if you see the case study, it's a face recognition. It has three steps. You face detection, then you extract the information with the features, then you classify and you identify the person. And of course, with that, the way we set up that to demonstrate this capability is with the server configuration with the Intel i7 with the NVIDIA graphics card, and with the edge configuration with the thin client with the LAN and camera interface. And we work with different models, different frameworks that you heard from a Xilinx talk and Blaze. The software is enabled so that all these software models are available as an open source. So our teams are familiar with these frameworks and various detectors like YOLO, and RCNN and classifiers, FaceNet and ResNet, etc. So we use these models and using the data augmentation algorithms to enlarge the data set using MosChip pre-processing engine. We actually developed this capability of the face detection. I like to run that demo as a video for that today. So with that, let me run that video. So that is the audio. That's the demo for the face detection, and we're continuously evolving more models and developing AI capabilities so that our platforms can support our customers' development. The idea of a platform is to eliminate the risks so that we can develop this custom ASIC for our customers in both silicon and software and systems to meet the time to market advantages. So to conclude my presentation, on-device embedded AI and security and non-volatile memories will drive the need for ASICs for edge devices. A domain-specific ASIC platforms will dominate the development associated for edge applications. And MosChip ASIC platform and system design solution will enable customers to develop and bring up these custom solutions for emerging consumer and industrial applications. With that, I'll take few questions from the audience.
Thank you, Mr. Swami. It was an amazing